She's watching right now, she's streaming. Or it's just, unfortunately, this is on hbsd.net, so it's like, your mother could be saying, what are they doing in class? Or something like that.
Why don't you have it as unlisted and put it on the classroom?
It is unlisted, but it's a live stream.
Mm.
So after they're saved, but you still go on the playlist, you gotta hunt it out, what you have to do. But, anyway, it is what it is. So what are we gonna talk about? Here, warm up. Here's a warm up.
18.
That's a fraction. Each box is a digit.
Mm-hmm.
Let's see how you guys compare to my 8th graders. And you may use the digit, you may use the digits 1 through 9, but you may only use a digit once.
What about? Okay.
There are more than one answer, believe you me. So I'll do attendance if you work that out. Yes, ma'am, you got one?
Mm-hmm.
Awesome. Get another one. You got one?
Hmm?
Do you have one?
Mm-hmm.
Really? You're stuck?
Sorry, I'm just still pondering on how I'm supposed to factor this stuff. I'm not very good at these ones.
Well, it's not factoring, it's a fraction.
I know, well,
No,
I was talking about
Oh, come on, this is a warm up.
I'm not good at these things.
Oh no.
Oh, I got
So
one.
Haley asked if we recorded a lesson today.
I got
I'm already pretty slumped on number 1 for the homework and the distribution. It refers to doesn't make sense to me. We just started class.
Okay. Bum 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 bum.
So, maybe she's there now.
Maybe so.
She's
Hi,
like,
Haley.
But I want to do number 1,
Well, Haley, I want to do number 18. It's 24C, so you're just going to have to be patient. Maybe you should have shown up to class if you really wanted to.
Yeah, really. If you really want to know, maybe you should be here.
The product, is it exact value?
But there's no product up there.
What?
You mean
This here?
Mm-hmm.
What numbers do you have that work?
6 and 12.
And
5.
so 6, 1, 2, and 5. There's your digits. Anything else?
Mm-hmm.
I had, what did I have? I had 1, and then, I don't know, what did I have?
I don't know.
It was 1, and then 0.
There's no zeros allowed.
Oh, right.
I don't know.
Never mind.
Is that what?
3, 15, and 0.2.
3, 1, 5, and 0.2.
Mm-hmm.
Ooh. You had lots of them. You're into this. Yeah?
8, 20, and 0.4.
8? No, 20 doesn't work because you can't use a 0.
Oh,
1 through
yeah.
9.
Yeah, okay. Times 4.
That wouldn't be
I had
bad.
one 8th grader put like 8 of them on their paper.
Well, you could do, oh no, you can't do 0.
That's
Never mind.
awesome. Whoa.
I gave them a little more time. Yeah, this is some math stuff.
You could have
Open-ended.
1 and then 1 and, or 0 and then 1.
Open middle is what this is. It comes from. What is it? 1 and
Oh no, I'll just be gone.
back to 0 again. You're really focused on that there.
Yeah.
Well, let's do that.
I just don't know how I managed to not know how to factor at the end of the homework assignment. So I was able to do it for the rest of the
It's exhausting. It can get exhausting.
Yeah, and I don't give you enough factoring. you need more factoring for what you go into. In college, you have to do a lot of factoring.
Well, we'd
those
probably
types of
want to do
courses.
it, because if you don't, then it's probably gonna be a lot more of a pain.
Yeah. So, what do you wanna ask? You wanna ask a question? Haley's was saying number one, but I bet that's number one on 7-8, and we'll go back to that after we do 7-7 questions. If you have a 7-7 question, Haley, you should like text me or email me, and I'll watch. 18,
Yeah.
what else?
Yeah.
And then 24C, I wasn't quite getting the right factor.
So let's do 18. So you have p of x is x to the fifth minus 10x cubed plus 9x. We need to find the zeros by factoring and verify our results by graphing. So how many zeros are there? 5.
Yeah. I was just
How many
getting-
real?
I got to the, I don't know.
1 for sure.
Yeah. Well, that's the part I got. I got to x, and then for some reason I was getting stuck in when it was a 4th degree polynomial that I had to factor out. I got x times x to the 4th minus 10x squared plus 9.
Okay.
But then for some reason my brain stopped working.
So let's put something up here on the board, huh? So, would you read to me what it is?
X to the fifth minus 10x to the third plus 9x.
Okay, and then you factor out an x right away?
Mm-hmm.
And then what?
That's where I was getting stumped for
That's
some
where you
reason.
get stumped, huh?
Yeah, I
Okay,
don't know
well,
why.
let's just factor the thing if we possibly can. Let's just think of this. What does that have to be?
X to the
squared.
second.
And that's okay, because when we take these two numbers and multiply them together to get that, it's gonna be times, it's gonna be like this.
Mm-hmm.
Okay, so this has to be 1 and 9 or 3 and 3.
1 and 9.
And they both have to be what?
Negative.
Negative.
Negative 1, negative
1 and negative 9. So there it is. It's factored, isn't it? Sort of. You're down to 3 factors.
9. Yeah.
But then you have to change, so
Oh!
Oh, I don't know how I didn't see this.
So this
before.
right here is a factor, but then we gotta take x minus 9 and we gotta factor it.
Mm-hmm.
So it's gonna be x times.
It's gonna be, isn't it
X
a
minus
squared plus
3.
b? Or, cause that's x squared plus 3 squared.
This,
Or minus squared 3 squared.
this one gets used a lot
Mm-hmm.
in upper level math. They bring in a difference of squares all the time. So a good thing to look for there is a difference of squares. So this is x squared minus 3 squared.
So it's the same as
X plus 3
X. Yeah.
x minus 3. And the other one's gonna be x plus 1 and x minus 1.
Okay. I
There
don't
they
know how
are.
I
So
didn't
now your zeros
get
are
that.
0, negative 3, 3, negative 1, and 1. 5. And you can graph it.
So, and there are no complex.
There's no, because you have all 5 accounted for right there. So,
And that's, we know that there aren't gonna be any complex, solving it algebraically, because we didn't have to use the quadratic.
Well-
we know this because it's
Yeah.
factored out as much as it can be here, and there's 5 values, so.
yeah, we
can
got
just see
5
what
values and there are 5
Mm-hmm. Okay.
because of the highest degree.
I mean, you could use the quadratic and still get perfect answers.
Yeah.
Okay, then let me see if she sent me anything just in case.
I think they were going to,
Or
Okay.
C was a very silly dude.
Alright, so 24C. So F is x cubed minus 27x.
And then g of x is equal to quantity x minus 2 cubed. Yeah, like that. And then subtract 27 times quantity x minus 2.
Just like that?
Yep.
So what are we supposed to do? Find the x and the y-intercepts of the function f. Did you do that?
I didn't know how to factor it.
Well, the y-intercept is going to be when x is equal to 0.
Right.
So the y-intercept will be, if y is equal to 0, that thing has to be, no, I'm sorry, it's when x is equal to 0.
yes, x.
X is equal to 0, so so the origin is the y-intercept. Okay, that?
It's the x intercept that was.
Yeah, I know, but I don't jump to the third one because I remember doing that last year with a student, and they had done A wrong, and they told me where we should start, D or whatever, and we never got there, and we just,
Yeah.
so when you don't know where to start, go back to the beginning. State whether F is odd, even, or neither.
Wait, I still don't know how to find the x-intercepts.
Oh,
That was my thing.
well, how about the Y-intercept? Because that's part A. You're able to do that? The Y-intercept is when X is equal
Well,
It's gonna
to.
be
part A
zero.
is X and Y intercepts.
Oh, it
on
is?
F.
Oh, yeah, okay, so the X-intercept is 0.
Mhm.
The Y-intercept, I'm sorry,
Oh, wait.
the Y-intercept is 0, right here.
Oh,
And then
okay.
the X-intercepts are when Y is equal to 0.
Yeah.
So then, when 0 is equal to x cubed minus 27x, we wanna solve that.
Isn't that a,
So it's x times x squared minus 27.
wouldn't we be able to factor out the X and then do the difference of squares? Or sorry, difference of cubes? No, squares.
It's not x to the 4th, is it?
It's not X to the 4th.
Okay, so then,
Wait,
so we have to deal with this right here,
Mhm.
x squared minus 27. Is this a difference of squares? It's a difference, and that's a square, so it is.
it's
It
This is how I'm gonna do it.
Okay.
So you need, this is gonna be like a new, It's the square root of this value on each side.
Oh, so it's
Aha.
They're done.
There we
So
go.
now you have your three roots. 0, root 27, negative root 27.
It's g of x too, that was really throwing me through a loop. For the
Okay,
x
so for
intercept.
G, the Y-intercept is when x is equal to 0.
Yeah.
So that's negative 2 cubed minus 27 times negative 2. So what's negative 2 cubed?
It's a negative
positive
4.
Huh?
Negative 8.
Negative 8. And what's this?
54. Positive 54.
So 54 minus 8.
What?
It's
46.
Okay, so the Y-intercept is 0.46. So the X-intercept,
Wait, what?
It's so
No, that is one of the
goofy.
X intercepts.
Huh?
Because we made Y equal to 0. So,
here,
oh, sorry, you
No.
went to the other side. I
this
see.
is
I see.
the
what you're doing.
Y-intercept
Yep, I see that.
when I set X to 0. So I'm gonna do the X-intercept, and Y will be set to 0.
Okay.
So 0 is equal to okay. So start factoring, start looking for common factors like we looked for here, we pulled an X out. We looked here, we pulled an X out. Is there a common factor in each of these terms?
Yeah.
This is a term, that's a term. What is it?
X minus 2.
Okay, so this is x minus 2 times x minus 2 quantity squared minus
27.
oh, wait a second, I gotta write this, I gotta write this all better. So x minus 2 as a common factor taken out of x minus 2 squared minus 27.
Oh, yeah.
So there we go.
That's what you do.
Okay, so now we know a root is 2, got 1, but we gotta figure this out.
Difference of squares.
So that's a difference of squares, so that's x minus root 2, x plus square root of 2.
Wait, why wouldn't it just be 2? Because we're already taking 2 to the second. Because we're distributing
Oh, shoot,
the
what-
square.
Yeah, wait a minute, it's not even a difference
Well,
of squares, because that would be
why?
x squared minus 2 squared.
Don't we distribute the exponent?
It would be x squared minus 27.
Can I do
27,
this?
right?
Can I do x minus 2 times x minus 2,
Yeah, let's do that.
and then subtract 27? Okay, so,
Oh,
so
right.
how many are we looking for?
3.
3, how many do we have?
3.
Multiplicity, we got it.
what's?
2, 3 times over. X-intercept the roots is 2 with a multiplicity of 3.
Yeah, I just wasn't seeing that, taking the
Yeah.
out of both of them. That makes it nicer though. Nice.
Nice.
Okay, alright, now, can we go on?
Yeah.
Okay, this one you're going to watch me closely.
Advanced factoring oh, this is the fun one.
Yeah, this will get complicated. Okay, so, you know, we're looking into an equation and we're looking for like a pattern within a pattern in this particular lesson. Now, I just want to walk through the best that I can with you each of these problems. In the first one, we have to factor t cubed minus 3t squared minus 4t plus 12. And you can't, you know, if you start looking at it, you can't pull a t out of everything because it doesn't exist. So what we can do is we can look at this in pieces. We can say that there's this, and then it's subtracting this. And what we see in here is that there is a common factor. And in here, there's a common factor. So we're breaking it apart, and we're saying, well, in this part of the equation, the common factor is going to be
T.
t squared, so t minus 3. Okay, because remember, all we're doing is factoring it. So we're just trying to break it down into things that multiply together.
Oh, yeah.
And then we subtract, and we have a common factor over here of
4.
4. And it's 4 times t and 4 times
Plus 3.
plus 3. Is that right? Negative here. So this is 4t plus 3?
Oh, no, it'd be negative 3. It would be minus 3. Because
Well,
negative 4 times negative 3 is
If I
positive.
did this, then I get a negative 4t, right?
Mm-hmm.
And if I did that, I get a negative 12, so it's got to be subtracted. Okay, so now, are we there?
Mm-mm.
What's wrong?
Oh, I mean, like, we still have more steps.
Are there? What do you have to do?
Well, kind of like what we did in 26. Like, how we had x minus 2. Well, now we've got x minus 3. So we want to take x minus 3 out of it. Like what we just did. Right? Because it's not factored.
So with the 3,
Well, here's t times t.
0, 3.
Yeah, so now what? Oh, shoot. Oh, yes. Oh, yes.
So like what we just did on number 26 in the homework.
What did we do?
We factored out x minus 2, so now we want to factor out x minus 3, so that we have x minus 3 times
Okay.
like a bracket.
So this is a common factor. And that common factor gets multiplied by t squared,
Mm-hmm. Minus 4.
and this common factor gets multiplied by negative 4.
And that's the difference of squares.
Wait, can you do that again? Sorry.
So what we did is we looked here and we looked here, and this is a common factor between both of these. Because we have if this was all multiplication across, we'd be done. But we have this plus this, so this is a term, and this is another term. So this has a factor of t minus 3, and that has a factor of t minus 3. So that gets pulled out in front, and it's a common factor. So t minus 3 times t squared is this. T minus 3 times negative 4 is this. So now here's one of my roots is 3. So if you're thinking roots, we don't have all the roots yet.
Difference of
Minus
squares.
3, and then t minus
Plus
2,
2 and
minus 2.
Yeah, so we're looking for what, 3?
Mm-hmm.
And we have them all right there.
Oh, that's
See,
nice.
that does it.
Oh,
Wow.
yeah, semicircle.
Okay, and then the second one we have to factor is quantity x squared plus 4x squared. 7 times x squared plus 4x note they're the same, plus 12. So if you think of this as substitution, this is how I was taught it. I always taught this as substitution. They call it chunking. This term is squared. This is 7 times the term, and then there's 12. So that follows a quadratic. So if you think of this here as like u and u, so what I did is I substituted, and I said that u is equal to x squared plus 4x.
Okay.
So that is kind of the substitution. So now, can you factor this?
Yes.
What is it?
It'd be
Yeah.
U times U something.
U plus 3 and U plus 4.
Yep. Yeah, baby.
Okay. So those are the two factors, right? But u is equal to this.
Okay.
So I come back and I say x squared plus 4x plus 3 times x squared plus 4x plus 4. And then I factor further. So I look at that one. There's x squared plus 4x plus 3. What does this become?
That's going to be a weird one.
Well, it's just gonna be x plus 3
It'll
and
be 1
x
and
plus
3.
1.
1 times 3, 3 plus 1.
And then this other one's gonna be the same except it's 2 plus 2 on both.
So how many roots do we have now?
4. We got
How many
him.
do we need?
4.
4.
Second. 2 times 2 is 4.
Yes.
And you graph it and everything.
I don't even know how to
Okay?
shorthand that.
Should we do another one?
Yeah.
Yeah.
We want to graph x squared plus 2xy. And this is one that I kind of struggle with. Y squared plus x plus y minus 2 is equal to 0. So, if you see anything in there that can be broken down,
I mean, it kind of looks like at one point it was like x plus something multiplied by y, or no, x plus something squared plus
Divide the whole
y
thing by x and
plus
divide the whole
something
thing by
squared.
y.
what is this?
That's the special thing. where
That's
it's
the
like, if
difference
you-
of sum.
If it was multiplied by something on the outside, then it would be the difference of cube, or squares, sorry.
No, it would be
Oh, no.
difference of cube. It would be
Oh, right,
sum of
cubes.
cubes.
Yeah, yeah,
No,
sum.
difference. Because then it would have the x.
Difference is the one where it's only pluses.
Yeah.
But
And
It
then
was a
that
piece
x.
of that cube problem, you know, the cube theorem, yes, or the odd powers theorem, but this is more simple.
Well, you could just take the square roots of that. So it'd be x plus y plus y, or plus x.
It would be x plus y squared.
X y. X plus y.
And then there's x plus y right there.
Oh my gosh.
Whoa, it's like what we just did. So that xy is equal to u. Okay.
So if x plus y is equal to u,
And then it's 1 plus negative.
u squared plus u
Plus u
So we positive 2 and negative 1.
minus 2 is equal to 0. So now what is this?
U plus, or u plus 2 minus 1. Or plus 2 u minus 1. Whoa. So then it simplifies to x plus y plus 2.
So now we come back, this is
X plus y
plus 2.
quantity x plus y minus 1.
Does that get us to the point where we can graph it?
don't we have to then, do we wanna simplify those to x? No.
Yeah, this was the one that I get a little mixed up in.
I'm not sure.
I'm wondering if
Do
we're
you
going in.
take out the common, would it be x plus y times 2 minus 1?
I think we're okay right there.
Harley? So you wouldn't take out x plus y on the outside?
Oh,
So
Oh.
you have xy times 2 minus 1?
So you'd have x plus y times 2 minus 1. No, because x
No.
plus y is not multiplied by 2. So that's all addition in there.
So that's all you need to do?
Yeah. This one here, then I think, yeah, if, let's do this. Zero product property says that each of those quantities could be set equal to 0. So either one of these is going to be equal to 0. So let's write the first one. X and y and 2 could be equal to 0, right? Secondly, x and y subtract 1 could be equal to 0.
would we do a system? Would we do systems then?
Well, I don't think we don't even need to do a
You
system.
could just do x minus 2 equals y.
Is this x minus 2 equals y? So
Yeah.
subtract x, subtract 2.
Yeah.
Y is equal to negative x minus 2. And then if I subtract x and I add 1, y is equal to x plus 1.
Minus x.
Minus x plus 1, yeah.
Oh, I'm sorry, negative x
Yeah.
plus 1. So you have two parallel lines that have different y-intercepts, negative 2 and 1. So this equation,
It's not a function,
right, it's not a function, it's an equation.
okay.
They don't say graph the function, do they? No, I hope not. No, just a graph, it's an equation. So if you were to graph this thing, it does this at negative 2 and positive 1. Both of them have a slope of negative 1. So this graphs into two lines. Is that okay?
Wait, so if you graph that nasty looking thing at the top, it's gonna produce 2 lines?
Yeah.
That's so weird.
I think you can ram that one into Desmos. I think Desmos has the ability to do this. You
Yeah,
wanna
because
look?
you'd have to, if you wanted to get that in our
Graphing
PA
calculator?
calculator, we'd have to put it in terms of y.
Like
Yeah.
Desmos is superior.
Should've been.
What is Desmos? So you have to say something equals something, right? So if I say
It's equal to 0.
0 equals, and then what is everything?
X squared plus 2xy plus y squared plus
Graphic.
x plus y minus 2.
Yeah, it gives you two lines on Desmos.
Whoa, that's funny.
I love that it keeps like building the thing as you.
I know, yeah.
Whoa! I did something wrong.
Let's do one more so you can work.
Oh.
There it is.
There we go, I did it.
Epic.
That was 3.
Wow. Why didn't we just put in a Desmos?
Because we're mathematicians. Find all the real solutions to x cubed minus, or no, equals 1. So we want to find the solutions by factoring, and then we want to use that result to find the non-real solutions to x to the 6th minus 1. So if you just graph it, that one you can put into your graphing calculator, right?
Yeah.
Yeah, so you just say, you just go and say that
Oh wait, I don't know if you could.
x6, yeah, like this. So this here would give you the roots.
I hate that. Why would you do that?
This gives you roots. This gives you all solutions. But if we set y equal to 0, then we find the roots. So you can graph this thing, and when you graph it, it is like,
Whoa.
it's like this. It's like a really flat-bottomed parabola. And it's gonna cross at 1 and -1. Okay, and it goes
Would it-
all, oops, I'm not going far enough south. And it goes down to -1. Okay, what were you asking? What?
Because if it's -1, then that's a positive number of negative. Oh, and then, okay, wait.
Why does it have a parabola?
Because if it's -1,
Even.
if it's -1, then it's -1 times -1, -1 times -1, -1 times -1. That's 3 positive ones. And then that is subtracted by 1, and that equals.
Maybe.
Why is it? I
Oh, I
graphed it.
see. I see. Yep.
I graphed it
Okay,
in
I see it.
Desmos and it's just continuous. It doesn't have that parabola. So I'm not sure.
What do you mean it's continuous?
As in, like, the answers are just x equals 1, x equals -1.
Oh, yeah, because you graphed you went for the roots. So it's graphing the roots on the x-axis, it's graphing your solution.
Oh,
What I'm doing,
I
I'm
see.
just setting it, I'm
I
just
needed
doing y.
There we go.
So
Okay.
that's this one. Roots,
Oh yes.
you can graph the roots, yes, but I want you to be able to factor. You're supposed to be able to find this by factoring.
Okay.
That's one of the parts of this. So we're gonna take x to the 6th minus 1 is equal to 0. We're gonna factor that thing. So what do you see in there that we could break apart? X to the 6th minus 1 could be rewritten how? Yeah?
Difference of squares to the second.
Yeah. If you think of this as x cubed squared minus, you can do 1 cubed squared. Now you have a difference of squares.
Wouldn't the whole thing be quantized and then to the second? Like, wouldn't it be x cubed minus 1 cubed quantity to the second?
Well, x cubed minus
Oh
1
yeah,
cubed
that's right.
quantity
Is
squared.
something totally different.
That's the square of a difference.
Yeah, that's totally different.
Not it.
Okay.
So, are you with us?
Yes.
Are you bored?
No,
You're
I'm
staring off.
listening. I'm just like looking that way. My ears are this way.
Looking that way, listening this way, and thinking the other way. Okay, so this is kind of like u squared minus v squared. So if this is u and this is v, this is like u squared minus v squared, which comes out to u minus v times u plus v. So then, if this is u,
Wait, why wouldn't it? Okay,
x
okay.
cubed minus 1
Mhm.
times x cubed plus 1. And we don't have to take 1 to the 3rd power because it's still 1.
Yeah.
So this is think substitution if you want to. Okay, so now you have x cubed minus 1 and you have x cubed plus 1. What can you do with those?
You could do
Smile.
the subtraction or for the one you can do the difference of cubes, and the other one you could do the sum.
You could. You apply a theorem. Oh my gosh, what a big pile of mess that is. Do you remember them? I wonder if that's what we're supposed to do.
Yeah.
I don't.
So you could do x to the cube minus 1 cube, and then that would be the super fun thing.
X to the cube, x minus 1, quantity x squared plus 2. No, 2x plus
Yeah.
1.
Yeah, so I think that's the only route. Okay, so this one here, is that right? Do we do them both?
Yay!
Gonna have to.
If we use a cast.
Wouldn't it be super funny if I feel bad and I decapitated myself? Laugh out loud. Be like, Kaylee's texting me, she's like, oh my god, my game was so great. I'm like, laugh out loud. Kaylee, and so did Daddy today.
It's like your mom.
Okay, so what's x cubed minus 1 by the theorem?
X cubed minus 1 is x minus 1, quantity x squared, plus x
Plus
plus 1.
Plus 1?
Yeah.
And then this one ends up being
X plus 1.
x plus 1?
Mm-hmm.
Yeah.
And then it just ends up with a negative, right?
X squared
Yes,
minus
minus,
x
and then
plus
plus.
1. Plus 1. Is that right?
Yes.
Yay.
Okay, so let's keep going.
Why?
Can this be factored
Yes.
into?
X squared, or gosh,
X
X
plus
plus
1
1, X
minus 1.
minus 1.
Wait, no, it would be plus.
No,
Yes.
No, that doesn't work, does it?
Doesn't work.
because then you'd have 2X.
Right.
Oh, poop.
No, it doesn't work.
Oh, it doesn't work, dog.
Uh-oh.
Let's do this over here.
Poopy. Okay.
Does this work?
Yes,
Yay.
it does.
X minus 1, x plus 1?
Mhm.
Yeah.
That's a difference of squares. What difference of squares?
Wait, it's x plus 1 and x minus, it's x plus, it's,
It
That
should
one
be.
doesn't work.
Oh no, because then it cancels
So what do you
out.
gotta do?
cry.
Use that.
Wait, no, we've got this.
Use technology.
Okay. Mm-hmm.
Ask for. Oh god, we gotta do the quadratic, don't we?
Yes, we do. Yay! 4AC
Inch 4.
all over 2. So it's a negative
Oh,
half.
that's so nice.
Are they imaginary? It'll be root 3i. Our I root 3. Strange magic.
Don't forget that too.
Uh-huh.
Plus
Plus,
root 3. I root 3 over 2.
Okay, so there's one,
mhm.
The other one's the same, just subtract.
the conjugate pair. There's the other. Here's one.
Uh-huh.
1, 2, 3. And then we come over here and we say -1 plus or minus
Dude, this is so awesome.
square root of b squared minus 4ac, right?
Mhm.
Yeah.
All over 2.
Mhm.
So
Wait a
it's,
second, hold on. B is
it,
positive, because that's a -1 and the opposite of B is
Yeah.
a positive one.
Yes.
So we have the same business with a positive 1. So then we have a half plus I over 2 root 3. And a half
Minus I.
minus I over 2 root 3.
We've got 6. And then that one.
yay.
4 imaginary, 2 real. And there's 6. We've used a bunch of tools. I hope Haley's watching.
That's so pretty. No, she's had questions on the homework. She already went through all this.
No, so I got the number 1, I was just looking at it. We're just giving you a hard time because you're not here. We know you'd beat us up if you were, so. Factor the polynomial by rewriting it as t cubed minus 4t plus quantity negative 3t squared plus 12. And then by applying the distributive property twice. Rewriting it. Well, are we doing this together or since she had number 1, we're all gonna do it on the board. Should we change colors?
Yeah.
I think when I was taking a picture of the board, there's some breaking news that Tiger Woods got injured. Golf will never be the
She
same.
got injured? Or he got injured?
Yes.
Why?
It's just a rollover accident, and then I stopped reading because I didn't want to get penalized.
Stop the world, Tiger Woods.
Oh, really?
Oh no.
Are those the
I'm
questions?
all-
Because Tracy Wyrick was asking about them.
I have them printed out for her.
Yeah,
Yeah.
we were talking at lunch
So
outside.
why would you purposely
I
do that?
have them printed and she's gonna join Alex.
Oh,
So,
she knows she's gonna do it because she told me she's joining you.
Yeah.
Okay,
Or I sent her an email.
all right,
Either way, but so I'll just turn them over there.
sweet,
And I have questions for
okay.
her. All right.
So let's do one together. And the basketball player can follow with us.
Oh, wait, is the basketball player there?
I don't know that she is, I told her to,
She's on her way to press.
oh,
I just thought if it was live, I would say hi.
cause it'll be
Bro, you're
recorded,
just
you can still
alive,
say
that's
hi.
hilarious.
Hi, Haley. Have a good game tonight.
No one likes,
Actually, I think they're going in batches before that.
Load up the cannon with 5 of them. It's the safest way to travel,
by cannon.
by cannon,
I learned by example.
lots of air movement.
when I'm doing that.
So we're gonna factor negative 3t what? Don't make me do this alone.
Wait, where is this?
Okay. So this is number 1.
Oh, to here?
So
Oh,
factor
oh,
the
I'm gonna write that down.
polynomial by rewriting it as. Okay, so this is the first example. So the first example was t cubed minus 3t squared, so we changed the order of it. Did you see that?
Mm-hmm.
So they changed the order of the terms. So now that what they have up front is t cubed minus 4t, and then they have negative 3t squared plus 12. So what we're supposed to do is apply the distributive property twice.
Do we wanna do, so this is for on page 489? We can use
Well-
grouping.
Yeah, what do you wanna do?
Grouping.
Grouping, okay, so then how you handle each side?
Let's
Simple.
group, we can do the same thing that we did for the first example. We take t out of the first grouping, and then we take negative 3 out of the second grouping.
So t times t squared minus 4,
Yeah.
and then over here we wanna take what out?
Negative 3.
Negative 3 times
T minus
ooh,
4.
t
Minus.
minus 4, but that doesn't work, does it?
It doesn't work.
So then what do we have to do to this to get it down to that degree?
We wanna factor it. It's a difference of squares.
Wait, why are we working from that one?
And, oh,
That's not the original one, that's the one we're trying to get to.
We're supposed to rewrite the first example like this.
Oh.
So Azella says factor a t out of the one and a negative 3 out of the other.
like grouping.
Do I have it written correctly? Let's just triple check.
T cubed
Minus 4t
plus t negative 3t squared plus 12. Yeah, that's right.
Okay, so
Oh, t squared up there,
where?
very top.
Oh,
Negative t
yes,
squared.
yes.
Oh, this is t squared?
Cool, yes.
Oh, good, then that makes the world all happy, doesn't it? Okay, so now,
I'm being.
here's our common factor
Mm-hmm.
out front of
T minus 3.
t minus 3, so what can you do with this?
Difference of squares.
Difference of squares. T plus 2, t minus 2, t minus 3.
This is so cool.
Erase, done. Verify the factorization by paper and pencil multiplication. So that means to multiply them out. Make sure you get back to where you started. Can you do that? Take the binomial times the binomial and you'll get a trinomial? Yeah, so these two guys here. And then you have to make sure that that gets multiplied by this binomial.
Uh-huh.
So then, and then you have negative 3.
Something happened.
Nope.
T, or 2t minus 2t is 0.
Where?
Because we're not gonna have, on that second line, right, no, up, this, and this is gonna be 0, so that's not definite, right?
You're right, what a, jeez, what a blow that was. Almost as
Yeah, I
good as
figured
the
that out and then
story.
whispered it to Zella.
Yeah, this whole thing's a mess. We're not recording anyway.
Oh, so Haley's question isn't gonna get answered?
Like the one question she had.
Minus 3t squared minus 4t plus 12. Oh, it just comes like right back.
Something went down in the coffee can.
It's okay now.
What are you talking about?
Oh, I see, never mind. Your exponents are like traveling. They're going south, they're migrating.
I don't like this board. Writing on this board is really, I don't like it.
Blame it on the board, Mr.
Well, maybe you should
It's
just
the
try to be
board.
shorter. I don't see any effort.